Kirkman. All right, ladies and gentlemen, here we are with our last video for Module 12. We are going to be looking at independent and dependent variables. Now, I know in class we've been talking about independent and dependent variables as well as in our notes a little bit, but we're going to add on and really practice and focus on identifying independent and dependent variables in tables, graphs, and word problems. So, in our notes, we are going to say an independent variable is the fixed variable or the constant. It can be represented by the x coordinate and is sometimes called the input. So these are the numbers that we put into our equation. So if I'm looking at the equation y equals mx, our independent variables is our x. Okay, it's what I'm going to put into my equation. It is usually consistent or fixed in a word problem, although it can change based on the situation. So it doesn't get changed due to a different variable. It changes because of the word problem. So if Sally bought 4 tickets, X might be 4, but if George bought 5 tickets, X might be 5. So in Sally's problem, 4 is X, and that's fixed. But in George's problem, 4 is 5, and that's fixed. Or it's not 4 is 5, X is 5, and that's fixed. Some examples of independent variables are time. Time, it just goes along. It doesn't change because of anything else. And the number of items you might buy at a store. Dependent variables are the ones that vary. So a dependent variable is the responsive. Thank you. Responsive variable. It responds to the independent variable. It is dependent on the independent variable. So in the example with Sally, if Sally bought 4, then the dependent variable might be the cost. Your cost will depend on how many Sally bought. So that it depends on that 4. It can be represented by the y coordinate. And it is changes based on the independent variable. So an example might be total cost, anything that it's going to be the solution. We also say that it's our output because, again, in the equation, it's going to be y, it's going to be what we equal. So I'm going to put in x into my equation. I'm going to get out y, depending on what x is. All right, so here are some examples. In a horizontal table, independent variables and x's are always on top. Dependent is on the bottom. In a vertical table, your independent variable, which is x, is always on the left. And then your dependent variable, or y, is always on the right because your input here is on the left and your output is on the right. And then in a table, or sorry, a graph, your independent variable is your x-axis and your y is your dependent variable. So remember how we graph, and we always graph x first, then y. You might remember that x comes first in a horizontal graph. X comes first in a vertical graph if you're reading from left to right. So x is always first. Okay, so here we're going to just identify the 2 variables that they give us in these problems, and then we have to identify those variables as independent or dependent. So this first one, Jameson runs m miles and burns c number of calories. Those are our 2 variables. We've got miles and calories. We need to think in our head, which one depends on the other? Is Jameson running a certain amount of miles depending on how many calories he wants to burn? Or is he running a certain amount, or burning a certain amount of calories based on how many miles he's running? And hopefully you say that our calories depends on how many miles we run. Nowhere in our word problem does it say anything about Jameson trying to burn a specific amount of calories, so we're going to assume that our calories are just a result of the number of miles we run. For number 2, we have the more hours Brady practices, the better his test grade will be. So those are our 2 variables, hours and test grade. And we have to ask ourselves, does the hours Brady practices depend on his test grade he gets in the future? Or does his test grade in the future depend on the hours he practices? In this specific situation, because this is a test grade that we don't know yet, his test grade will depend on how many hours he practices. It's how many hours he studies. So the more he studies, the better his test grade should be. Down here, we are not given our variables as clearly. We have to figure them out. Michael pays $8.99 per month for his streaming subscription. What are the variables that change, right? We've got a streaming subscription and we've got costs. What are these things that change? So money per month, those are our 2 variables. So we have our cost and we have the number of months. Does the cost of our streaming subscription depend on how many months we've had it? Or does the number of months we have a streaming subscription depend on the price? It's going to be cost depends on months, because you don't say, well, I'll pay you $100 and you give me whatever amount of months I can buy. It's usually when your bill comes, it gives you a price based on how many months of service you've had that streaming subscription. Okay, number 4 is really short. A car travels 60 miles per hour. We're dealing with speed, and in speed, we've got 2 variables, miles and hours. Okay, so our 2 variables are miles, how many miles we've gone, and how many hours we've gone. Now, do the number of miles I travel depend on the number of hours that's passed? Or do the number of hours that have passed depend on the number of miles you're going? Well, time doesn't change for anyone, so time is definitely independent. Hours is independent. Miles, however, how far I go will depend on how many hours have passed. If I'm going 60 miles per hour, that will tell me that every hour that passes, I go 60 miles. All right, pause the video and try 5 and 6 on your own, and then join me and see if you're right. All right, so hopefully you figured out that number 5 is going to be the cost depends on the number of slices of pizza you buy. And number 6 is how sleepy Jesse is. And how sleepy this Kirkwood is depends on how late Jesse stays up at night. Now, number 6 could go the other way if the word problem was worded differently. If the word problem said that the sleepier Jesse is, the earlier they go to bed, we could flip-flop our dependent and independent variable. But because this word problem specifically states that Jesse stays up later, or when Jesse stays up later, then she's sleepier at school, we know that sleepiness depends on lateness. So pay attention to the way things are phrased. All right, that is the hardest part of dependent and independent variables, I think, is pulling them from word problems because they can be misinterpreted. Here we have a little bit easier because we know, based upon our notes here, that anything on the x-axis is our independent variable and anything on the y-axis is our dependent variable. Finding dependent and independent from a graph is a lot easier, okay? So tables and graphs can also display dependent and independent quantities. Here we have a graph and we have to determine the independent and dependent quantities. Paul is training for a 5K. What is the independent variable? Well, that, my friends, we're going to find right here, number of weeks, because X is our independent variable. Okay, our dependent variable is going to be Y, and that is total miles run. Now, when it says the word quantities, we're looking for numbers. So they really want you to list all of the numbers in this graph that are independent and listing all the numbers that are dependent. So to make it easier right now, we're going to pick points on our coordinate plane. Now, obviously, I could train for 1.5 weeks or 1.25 weeks, which is why it's a straight line. So I could basically do anything from 0 to 10 or 0 and up. Okay, or I can just list all of the ones that are given to me. And these are all the numbers that are here on our x value because x is independent. Okay. Now for dependent variables, we're going to pull those from the y coordinates. Okay, we are anywhere between 0 and up, or 0 and 30, or 0 and up. Okay, again, or I can skip count and write all the numbers that are on the side here. These are all of our dependent variables. All right, and then the last thing they want us to do is to pull back our recollection. This is a really good one to review what we have learned because we're now going to write an equation for this graph. So if you remember, we learned two equations. We learned a multiplicative equation and we learned an additive equation. Okay, we have to decide, is this graph multiplicative or additive? Well, if you remember from our previous videos, multiplicatives always start at 0, 0. And if I look, I'm always multiplying every x by 3 to get my y. I'm multiplying all my x's by 3 to get my y. So we're going to take a multiplicative equation, and our constant is 3. So our equation is y equals 3x. So basically, he runs 3 miles every week. Okay, now moving even easier, we're going to look at tables. We've got some horizontal tables and some vertical tables. We're going to identify independent and dependent variables, and then we're going to write equations for 8 and 9. So remember from our notes here, independence always on top, and then dependence always on bottom. Independence left, dependent is right. So all I have to do is memorize that, okay? So I know that this is x and this is y. So independent is hours, and dependent is miles. Same over here, x, y, months, and total cost. Then we go to our equation. So we are using either y equals mx or y equals x plus m. We have to find the pattern between x and y. Remember, I need to know what do I do to y to make it equal, what do I do to x to make it equal y? So I am looking from top to bottom in these tables. What do I do to 2 to turn it into 30? What do I do to 4 to turn it into 260? What am I doing here? I'm not adding because 128 plus 2 makes 130, but 128 plus 4 does not make 260. So we are multiplying. We know it's going to be y equals m times x. We just have to figure out our m. 2 times what makes 130? Well, if I do a quick 130 divided by 2, you would find that it is 65. And that is my equation. Same thing for number 9. If you want to pause and figure it out yourself and then check your answers, please do that. But we are looking from x to y, from x to y. We need to ask, is it multiplicative or additive? Well, 1 plus 299 is 399. 2 plus 299 is not 798. So we know it is not multiplicative, or sorry, not an additive. It is multiplicative. What times x makes y? 1 times what is 399? 2 times what is 798? And you should have figured out it is 399. All right, I would pause the video and see if you can answer the last 3 questions here. They're super simple. In a vertical graph, can you identify the dependent and independent variables? So hopefully you checked it out there and you would have gotten number of minutes and then total words, hours, and then inches of rain, weeks, and then total cost.